Marisol is mailing invitations to her quinceañera. The arithmetic sequence 0.66, 132, 198, 264 represents the cost of postage. So we're going to write a function, then we're going to graph it, and then we're going to determine the domain and range. So to write a function, we need to know a couple of things. Our function looks like this as usual. And the two things we need to know are d, the common difference, and a sub 1, the first term. Well, a sub 1 is easy. The problem gives it to us. It's 0.66. The common difference can be found by subtracting, let's just do the first two. 132 minus 0.66 is 0.66. So the common difference is also 0.66. Makes a lot of sense when you think about it, that our postage is going to be the same every time we buy a stamp. Okay, so here's what the equation looks like when we replace our d with 0.66 and our a sub 1 with 0.66. We can clean this up a little bit with distributive property, so let's go ahead and do that. 0.66 times n is 0.66 n, and 0.66 times 1 is 0.66. And at the beginning, we have a sub n equals 0.66. So this was our distributive property. And whenever we combine like terms, we're going to have a positive 0.66 and a negative 0.66 that are going to cancel, which means our function, our equation, is going to be 0.66n after we combine like terms. So what this is saying is every stamp that she buys costs 66 cents. Okay, let's go ahead and graph it. So we're going to do a sketch here. Our independent variable is going to be number of stamps, and our dependent variable is going to be cost of postage. So we only need the first quadrant because we're not going to have negative cost or negative number of stamps. And let's just do 4, 5, 6, 7, 8. That should be plenty. And then we'll do just do a few little marks here. And we'll just go 1, 2, 3, 4, 5, etc. 1, 2, 3, 4, 5, etc. You get the idea. Okay. So let's go ahead and put some points on here. So we know one stamp costs 0.66. Two stamps then would be 0.66 times 2, which is $1.32. Let's see, three stamps would be, let's see, maybe $1.98. So three stamps just under 2. Four stamps, 4 times 0.66 is 264. Five stamps would be $3.30. So 5 stamps just above $3. I think that's probably enough. Okay. So am I going to connect these points? Is this going to be a discrete graph or a continuous graph? It's going to be discrete because, remember, discrete means I do not connect the dots because I cannot have a partial stamp. I cannot buy 1.5 stamps. I can buy 1 stamp or 2 stamps, but I cannot buy 1.5 stamps. So I do not connect the points in this case. So what's the domain? The domain is the set of all x values, which is going to be the number of stamps that she can buy. That has to be a whole number, but there's no limit to how many stamps she could buy. So I'm going to do 1, 2, 3, 4, and then I'm going to put this ellipsis on the end that just says, could go up to as many stamps as she feels like. We don't know how many. Sky's the limit. Now, what about the range? The range is going to be the set of all y values. Again, we are going to have to list these out because she can spend 66 cents on 1 stamp. She could spend $1.32 on 2 stamps, but there's no way she could spend exactly $1. You can't spend exactly $1 when the stamps cost 66 cents each. So we'll just do, I mean, we did 4 for the domain. Let's go ahead and do 4 for the range also. Those are the first 4 values. And then we'll do this ellipsis here like that. So the domain is the number of invitations or number of stamps or whatever. Doesn't the same thing. We'll just say number of, well, let's say number of stamps because that's what we labeled it. Number of stamps. Number of invitations would be fine too. And the range is going to be the cost of the postage.